This video will describe production of some unique bowls that contain tapered layers. Layers that go from a thick to a thin area across the diameter of the ring. These are segmented rings, 24 segments per ring of alternating maple and bubinga. And you can see the layers are tapered, going from a thick area on this side to a thin area, and then glued up in patterns such as this to produce these unique bowls. I'm going to be cutting a bunch of segmented disc, 24 segments per disc, alternating maple and bubinga wood, and these discs are all 1 3/4 inches high. I'm going to be making a disc going from 4 inches in diameter up to 6 inches in diameter for this next project. So I set up my Accu wedge to 24 segments per disc, and we're ready to start cutting here. As I've done in previous videos, I have to sand the fuzzies off the edge. Just a quick sanding to get rid of those fuzzies. Okay, after the sanding, I put the pieces together, put a rubber band around them, and these are the disc. And once again, perfect joints. So these are ready to glue up. I have a bunch of these I set up for the different sizes, and I plan on gluing these with epoxy. I'm actually going to be setting this up on a jig that I made a couple years ago with various dowel pins and the rubber bands on here. Just pre-tension the rubber bands so it's much easier to put the parts on without them slipping off when I glue it up. So I'll be putting the parts, once I glue them up, right into this jig. Okay, and that's one done. We cut a series of 3/4 inch MDF discs, the same diameter as each of the segmented discs. These MDF discs will then be glued to the base of each of the segmented discs. As will be shown later, gluing these MDF discs to the segmented disc will enable me to cut segmented ring sections with no loss of material. I have all my rings cut here, going from 6 inches in diameter all the way down to 4 inches in diameter. I'm going to be cutting these at an angle, and so I make sure I use every piece of wood. I am mounting the blocks on a piece of MDF cut to the same circular shape. So when I cut this off, I'll be able to cut all the wood. I won't lose anything. In addition, I made some bottom pieces for my bowls. This is 12 segments going to a perfect point. And I've also made a couple of rings that will become top rings for the bowl when it's done. Again, out of solid wood. And these are 24 segments per ring, the same as the wedges here. So I'm in the process now just gluing these up. After these rings were glued up, I did sand the surfaces flat and took off some of the excess glue on the outside. So please clean them up a little bit before I go forward. Okay, what I'm going to be doing here is cutting 2.5-degree angles across this wedge. That's why I put this piece of wood on the bottom to mount in this fence. This is a fence I made in the previous video, which uses it as cam lock to lock the board in place. And what I've done on this also is I've tilted it. I put some spacers in here, so it goes from flush here to a 1/2-inch spacer here. So a 1/2-inch spacer over 12 inches gives me an angle of 2.5 degrees. So I'm mounting this on the bandsaw and the Accu-Slice. I'm mounting my wood using this piece of wood. Now I also, on my wood, I marked a line and then exactly 180 degrees over another line. And so what I'm going to be doing is I'm going to be cutting this, cutting one angle, rotating it 180 degrees and cutting the other angle. So I'll end up with wedges, 2.5 degrees on each side. I've also marked the line on my fence here, which is exactly in the same middle. So I align it, set it to the mark, and clamp it in place. And I got my laser beam set up to mark where I'm going to cut. I'm ready to do my first cut. This first piece cut is scrap. It will not be used in the project. So I cut this wedge off that piece of wood, going from nothing to about 3/16 of an inch. Now I'm going to rotate this board 180 degrees. Once again, align my mark. So I'm going from a narrow position here to a wide position here. So I need to determine how wide I want my narrowest position to be. I decided it's going to be a 1/4 inch, so I have a 1/4 inch spacer here. I'm just going to line on the board, and it's exactly at a 1/4 inch. So that'll be my first cut. And there's my first wedge. And you can see it's going from a narrow position here, which is just about 1/4 inch, and to the widest position over here is just a little over half of an inch. So this is the wedges I'm going to make going forward. So once again, I release my clamp, rotate the board another 180 degrees. And lock it in place. Let's see if I can determine how many revolutions I need to get my 1/4 inch. It's exactly 9 revolutions, so I'll keep cutting my boards. So now you can see what we've done, going from a narrow position here to a wide position here. Each been 2.5 on each side, so that's 5 degrees per piece. And if I take these and rotate them, you know, a 1/4 turn, I'll get something that looks like that. Or I could rotate these exactly 180 degrees and get something that looks like that. So we got a couple different ideas to play with here. So I'll keep cutting some more disc. Next go into the next larger board and complete the set. Okay, my thought in this first bowl is to make an angled bowl. That the top is not flat, top's going to be at an angle. So I'm going to do something like this, rotating each of these half a segment. And I'm going to glue these up 3 at a time, and I'll put them on a lathe, round them, glue another set of 3 up, and repeat that, and just see how that goes. It's kind of flying by the seat of my pants here, but we'll see what happens as we progress. So let's start gluing these up, sets of 3. I'm using Titebond glue here instead of epoxy because a Titebond glue has a faster setup time. After applying glue to both surfaces, the 2 discs are put together and rotated 1/2 segment. They are then clamped together using a series of spring clamps. To the faceplate glue block, I attached my first layer, which is this 12 segment per disc catalogs. And to that I'm going to glue on this first set of 3 and try and clamp it somehow that it holds in place. Only need the segments so they don't overlap. So we're going to do next. I decided to go ahead and glue on the second set of 3 discs, and I'll just turn it all up once. The glued up assembly of the 6 disc is allowed to dry for at least 8 hours before it is attached to the lathe. This operational lathe is dangerous and should only be attempted by highly experienced lathe operators. The item being turned is unbalanced and may cause the lathe to rock. The tapered edge on the assembly can act like a guillotine as it turns on the lathe. Use all lathe guards and keep your fingers and hands far removed from the revolving wood. Okay, I mounted this on the lathe. It's going to be interesting turning this, so I will be using all my guards. Turning the inside of the bowl can be very dangerous. Keep your hands and fingers far removed from the rotating wood. In fact, as a rule, I never take my hands past the tool post. Due to the vibrations of this out-of-balance piece, I was not able to run the lathe at a higher speed, which would have minimized this jumping and would have given me a smoother cut. So I deliberately took very small cuts and held the lathe chisel tight against the tool post in an attempt to avoid this jumping and chipping of the turned piece. What I'm trying to do here is to get the angled rim of the bowl the same thickness around its circumference. It's difficult to see and judge the bowl tip edge as I am turning on the lathe. Okay, I'm going to go ahead and glue this catalog ring, which is, again is 24 segments per ring, just to give me an accent strip. And this is cataloged the same as the base material. So I'll go ahead and glue that on. I think I'll take it off the lathe. I glued the top strip on, sand a little bit to get most of it off. Now I'll finish this off. I'm sanding the inside of the bowl with sandpaper wrapped around a 1-inch dowel, again to keep my hands far removed from that edge on the bowl. And this is a finished tapered bowl coming off the lathe, ready for finishing. This is the turning of a second bowl, which has 9 tapered layers. Because of the additional layers, one must be even more cautious when turning this bowl, making sure you keep your hands and fingers far removed from those edges on the top of the bowl. Due to the 9 layers in this bowl, the taper of the top lip is actually over 40 degrees. Because the top angled edge is so much longer, I am using a Carter lathe hollow roller. It provides for additional safety and tool stability when turning the inside of this bowl. In addition, I'm deliberately taking very small cuts, and I'm holding the lathe chisel tight against the tool post in an attempt to avoid any jumping or chipping of the turn piece. I sand the outside of the bowl, starting with 100 grit sandpaper, and then going down all the way to 400 grit sandpaper. For increased safety, the final sanding of the inside of the bowl was done by hand with the piece off of the lathe. I start to part the finished bowl off the lathe. I do not cut the whole way through, since I do not want the fragile bowl to drop. I finish the parting off with a handsaw. This finishes a segment of bowl with 9 tapered layers. The production of the tapered layers was easily accomplished with the offset cam fence on the Accu-Slice system. However, the turning of this 9-layer tapered angle bowl was quite challenging due to the piece being out of balance and with the angled lip of the bowl jutting out at almost 45 degrees. For increased safety, all of the inside sanding of the bowl was done by hand with the bowl off the lathe. From these alternating segmented discs, which was 24 segments per ring, I cut these angled pieces on the Accu-Slice. Then I assembled them 2 different ways. One way was all keeping all the layers in the same direction. And the other way is I kept them alternating, so I ended up with a flat bowl just by going back and forth. And this was the final one, which is a little bit larger one. This project proved to be quite challenging for me, mainly due to my inexperience turning pieces that are out of balance. My lathe is not very large, it's not a heavy-duty lathe, and is not bolted to the floor. As soon as I increased the lathe speed over 1000 RPM, the lathe started to rock and roll, which required me to reduce the lathe speed. The front lip or edge of the piece had an angle of almost 45 degrees, and it curved slightly inward. It was very difficult to see and judge the bowl lip edge as I was turning it on the lathe. And as soon as the lathe chisel touched the lip of the piece, it started to jump a little, which made me nervous. Due to the vibrations of this out-of-balance piece, I was not able to run the lathe at a higher speed, which would have minimized this jumping and would have given me a smoother cut. That is why I attached the Carter hollow roller to my lathe. It gave me more control and I felt safer. I also deliberately took very small cuts and held the lathe chisel tight against the tool post in an attempt to avoid this jumping and chipping of the turned piece. In any case, I used extreme caution in keeping my hands and fingers far away from the turning lip of this bowl. I used all the safety attachments at my disposal, including the cage guard on my lathe, a safety shield, and a respirator when turning this piece. For increased safety, the final sanding of the inside of the bowl was done by hand with the piece off the lathe.